This is the first part for video lesson for 7-3 for Secondary 2 Math. We are going to be talking about systems of nonlinear equations. Okay, to start us off, we're going to review some things that we've learned about circles. Number one, this one's an easy review. If you remember when we learned about circles, and we had the form of circles was going to be x minus h quantity squared plus y minus k quantity squared equals r squared. And so looking at that, our h and k right there, that's our center of our circle, so we're going to go over 2 and up 3. And then our radius squared is 9, so that would mean the radius is equal to 3. So I'm just going to make a radius of 3. My dots aren't showing up really good. And then we do the best we can to draw a circle. And that's the graph of the circle. Now for number 2, back when we were doing circles, we didn't have a problem just like number 2 because we weren't quite as advanced then. Can you pause the video and look at number 2 and figure out how would you think of using that equation to make it look like this? So keep in mind that on number 1, the way we had our equation was we had these two perfect squares added together. And so how can I create a situation in number 2? So I want you to pause the video and I want you to think about it and just maybe try something and see if you can come to some idea of how to make this into an equation of a circle. Okay, hopefully you did take the opportunity to do this, but here's what we would do. We were going to take the x squared and the 4x and we're going to separate them out. So I'm going to kind of scoot down here a little bit so I have some space. So x squared plus 4x. And I'm going to leave some space, and I'm going to do the y squared plus 4y. And then I'm going to put the 4, the constant, on the other side. Now, if you remember back when we did quadratics and we learned about completing the square, I can complete the square right there to make a perfect square, and I can complete the square right there to make a perfect square. So that's what I'm going to do. X squared plus 4x, to complete the square, I would add 4, so I have to add 4 to the other side. And then on the y's, I would add 4, so I would have to add 4 to the other side. So what I have is I have x plus 2 quantity squared plus y plus 2 quantity squared equals 4 minus 4 plus 4 is 4. So this is exactly the same equation as what we see right there, but in the red, we can now see how to graph that circle. So my center is at -2, -2, and my radius is 2. And so that's how you would graph that circle. So now that we know how to complete the square, we're able to create something that we're familiar with out of something that we're not familiar with. Okay, for number 3, this is going the other way around. So using the information, which of these would be the correct equation of this circle? So if we have a circle with center -2, 6, remember that's going to be x minus -2, so x plus 2 quantity squared plus y minus 6 quantity squared equals, the radius I don't know, but I do know a point on the circle is 0, -3. So knowing what I have already, I can look at my choices, because this is multiple choice, and I can eliminate that choice and eliminate that choice. It's going to be either C or D. So based on the point in the center of the circle, if I was to just do a sketch, so -2, +6, my point on the circle is 0, -3. That's a pretty big radius. Okay, is it about 9? Or is it about the square root of 7,225? I'm kind of thinking it's more like C. I'm going to get my calculator and check. So the square root of 7,225 is 85. That is not a radius of 85. So just by process of elimination, I'm going to say that this is the correct equation of the circle. Okay, and then for number 4, the same idea. So if my center is -8, -13, I'm going to have x plus 8 quantity squared plus y plus 13 quantity squared equals my radius squared. So again, I can look at my choices. This time I can only eliminate D as a choice. But looking to see, like at the sketch, if I have a circle with a radius at -8, -13, and -10, which is just 2 away there, and -11, that's a pretty small radius. I'm pretty confident in saying it's not going to be 8 because this would give me a radius of 8. So I'm going to eliminate that as a choice. So it could be 1, or it could be 2 square root 2, which is approximately 2 point something, 2.7 or something like that. So that's where I need to figure it out. So remember, we've got a couple of tools we can use. So one thing that we could use is I could take the negative 10 being the x and the negative 11 being the y, and I could plug it in. I kind of think it's that equation. So I'm going to just plug in for x. So negative 10 plus 8, quantity squared, plus negative 11 plus 13, quantity squared, is that equal to 1? So I've got negative 2 quantity squared plus positive 2 quantity squared, so that's 4 plus 4. Yeah, that's not equal to 1, but it is equal to 8. So if I plug in these points, I'm actually going to get that one. So that's one of the ways that you can do that. So just to review about how circles are, because we're going to be graphing circles today. And so moving on, previously we've learned how to solve systems of linear equations. So we've done that before, where you graph a line and you graph another line and their intersection is our solution. So today we're going to do systems of equations as well. But let's talk about the ways that you've learned how to graph or how to solve systems of linear equations. And the first way that you ever learned to do that was by graphing. And then after that, you learned how to use substitution. And all of these things we did last year as well. And then you learned about elimination. And then we got into matrices. And you learned how to use inverses with matrices. And do you remember the other ways? Kramer's rule. And we learned how to do reduced row echelon form. And all of those ways work really well with linear equations. And even if you have, 2 dimensions or 3 dimensions or whatever. So the problem that we're going to run into, though, is we're going to do systems of nonlinear equations. So we have exponents. And so a lot of those things aren't going to work. However, there are a couple of methods that we've learned before that are still going to work really well for what we're doing, and that is graphing and substitution. So those 2 ways that are probably the least efficient with linear equations are probably the most efficient with nonlinear equations. So you're going to go to the second video now, and we are going to learn how to solve systems of nonlinear equations.